All right, welcome back. 8.2, example number 2. The quadratic relation h equals negative 5t squared plus 210 describes the path of a rock as it falls from the top of a cliff, with h representing the height in meters and t representing the time in seconds. So if I wanted to get a little bit of an idea of what this looks like, now let's think for a minute here. Look at this. What's going to happen when t equals 0? So time is going to come across here. Well, first of all, we're only going to want positive time, right? And this will be 0. This will be as soon as the ball was thrown. So we're only going to be interested in time going this way. So the quadratic relation is negative 5t squared plus 210. So if t was 0, this whole thing would be 0, which means that h would be 210. So what you have here is a y-intercept of 0, 210. And we know that it's negative, so we know that it's going to open down. So I'm getting something like this going on. Okay. Now the vertex, I don't know where the vertex is. I really don't know, but I know that I've got it crossing somewhere like here. So the vertex might be here, it might come down, or the vertex might be somewhere up and coming down. It doesn't really matter. What I know is that when t equals 0, I've got a height of the rock of 210 meters. And I think that's my first question. From what height is the rock dropped? Well, if your equation is given by that, then when the rock is dropped, the initial time, so as soon as the rock is dropped, just before we let go of it, time equals 0, right? So h will equal negative 5, 0 squared plus 210, which will be 210 meters. So its initial height is 210 meters. Find the height of the rock after 4 seconds. Well, what we do then is we just change what t is. So we're coming out here to 4, and we want to find out what that value is. But we don't have the, that's kind of off to the side, there we go. But we don't have a graph to interpolate, so we have to use the algebra. So what we're going to do here is we're going to plug in 4 for t and work out the equation. So 4 squared is 16. 16 times 5. 16 times 5 is 80. So it's negative 80 plus 210. So 210 take away 80 is 130 meters above the ground. So at 4 seconds, it's going to be 130 meters off the ground. Is the rock still in the air after 7 seconds? Oh, that's a good question. I guess what we'll do is we'll find out its height at 7 seconds. So h, negative 5, 7 squared plus 210. 7 squared is 49, people. So 49 times 5 equals negative 245 plus 210, which is going to give us negative 35. Now think about that. So we're at negative 35 meters. So we're out here somewhere. We're at 7 comma negative 35. So is it still in the air? Well, unless it's falling into a hole that's been dug into the ground, or unless it fell off a cliff and we're measuring it from here, then no, there's not. It must have stopped somewhere before 7 seconds and hit the ground and stayed there. So the answer would be no. We assume the rock has hit the ground before 7 seconds. Now, if it fell into a hole and it's continuing to fall, that's a separate situation. Or if it fell off a cliff and it's continuing to fall, that's a separate situation. But given the information that we know, it is definitely going below ground level, and therefore we assume that the rock has come down and has hit the ground, bonk, and is sitting there as time goes on. And that time that it hit the ground must have been before 7 seconds. Now, we also know that it's after 4 seconds, because at 4 seconds, it was 130 meters still above the ground. So can we guess when it landed? I guess we could. We could keep playing with this until we came up with 0, if we ever did. So we know that it must be between 4 seconds and 7 seconds. Let's try 5 seconds. So when t equals 5, you're going to get a height of, now the question didn't ask for this, I'm just doing this because it's kind of fun. 5 squared is 25. So 5 times 25 is 125. Hold on here. Let's see if I'm doing this right. So 5 squared times 5, and that's going to be negative, plus 210, 85. So, sorry, I had my negatives goofed up there. So at 5 seconds, it's still in the air. What about when t equals 6? So then that's going to be 6 squared times 5. It's 180. So that's still in the air. What's that, 30? So sometimes between 6 and 7, it hits the ground. So maybe 6.5. 6.5 seconds. .5 times 7. What am I doing? 6.5 squared times 5. Okay, yeah, we've hit the ground. And we've just hit the ground, just for a little bit, right? So ideally at 6.5 seconds, I'm right about here. So I hit the ground just before then. Anyway, there you go. There's 8.1. There's some work for you to work on, and we'll go from there.